Excellent. Thank you very much for a very interesting talk. Let me see if we have any questions so far. Let me kick off with a question. So obviously today, the amount of NVM we have in a machine is large, but it's not super large. We're still talking about gigabytes generally, or maybe a few terabytes. Do you think that as this scales up and we end up building entire database systems or similar systems inside a single node, will the same sort of techniques that you've applied be helpful there? Do you think it'll scale to larger sizes, larger data objects, larger key sizes, more sophisticated schemas than sort of key value stores?
Could you explain one more time?
So at the moment, a lot of the work is looking at a key value where the key is an integer or a short string and the value is a small data item. And that's very useful, but obviously we store other things as well, more larger database systems, database management systems. Are there extra challenges to support those sorts of systems that you can think of, or do you think it'll just work?
Actually, that is a very good question. And if key size is more larger, then we can use some other techniques such as compression things, or to reduce the size of the strings or data to save the bandwidth, as we mentioned in the PEC guidelines. Did that answer your question?
Yeah, I think it'll be interesting. I think there's probably lots of challenges, but we have to wait. We have to solve one problem at a time. So thank you for the answer. We've got a live question from Sujanya, excuse me.
Hi, thanks for the great talk. So I was wondering what your benchmark setup was, evaluation setup, and if you were able to run all the systems that you compared with on your end on the same experimental setup.
We used 2 socket machines for our evaluations, and we also evaluate our persistent indexes with other indexes also in the lower bandwidth machines, and all of the evaluation results are in our paper.
So if I understood this correctly, you emulated persistent memory on your...
No, we used real NVM persistent memory.
And you were able to run like Fast and Fair, BZ-tree, and the other systems that you compared with on the same experimental, right?
Yeah, we ported other persistent indexes to use PMTK's persistent memory allocator to fairly compare the performance.
Got it. Thank you. That answers my question.
Thank you for asking.
Awesome. And I think we have a live question from Kim Keaton coming up. Yes.
Hi, Wook-Hee. Quick question for you about some of the future work that you mentioned on your last slide. You mentioned that these same kinds of ideas could be applied to different kinds of applications. And I was just wondering if you could say a little bit more about your experience doing that.
Actually, our PEC guidelines originally for designing the persistent indexes, but our guidelines to save the bandwidth and for concurrency control also can be applied to the performance critical software such as databases or file systems. For example, in databases or file systems, they generate large size of the write traffic. So in the cases we should save the bandwidth because NVM has limited bandwidth. So yeah, that is it.
Great, thank you.
Okay, and I think we have a question from Rohan. Please take it away.
Hi, thank you for your talk. So I was wondering if you are aware of the extended ADR mode of the new Optane DIMMs that are coming up, where you won't need to flush any caches and you get more bandwidth for smaller kind of IO. So I was wondering if the PAC guidelines will change in the presence of these new advancements in persistent memory hardware.
Do you mean the PEC guidelines in the EADR mode?
Yes.
As you mentioned, thank you for asking. And in ADR mode, as you said, we do not need to flush the cache lines to the NVM because CPU caches are in the persistent domain. But I believe still the NVM bandwidth is limited, and the crash consistency algorithm and concurrence things are still valuable for the EADR mode. So I think, except for the persistence overhead, except for guidelines for the persistence overhead, we can apply our PAC guidelines to the EADR mode also.
Okay, thank you.
Okay, I've got one sort of somewhat related question for you, and I may ask the other panelists to rejoin us as well. So one thing that it's been great to see, as I mentioned at the start of the session, is that we actually now have got real NVM DIMMs that we can use, right? It's no longer pretending that it's slow DRAM. And I think your paper in particular, Wook-Hee, discovered some things that had not been anticipated beforehand. But this is only the current implementation. This is what Intel has given us today, and maybe other vendors will provide other technologies in the future. So I guess the question maybe for all of the panelists to think about is, how much will we have to redo all of this work when the next generation of non-volatile memory shows up from the next vendor, or maybe the same vendor, but which has got different performance characteristics and different trade-offs?
I think this is a very good question, and I believe persistent memory can be replaced to other storage media or something else, but I'm not sure, but in the history, for the various storage media, we have some common properties for each, for storage media, and some things are specific to each storage media. So I think we can reuse some idioms from the previous work, but anyway, if storage media has been changed, then the case is we should redo these things to characterize the storage media, I think.
Awesome.
Thanks a lot, Wook-Hee. Perfect. Okay, we have a question. From Abhinash. Yeah, go ahead. You're already panelist.
Yeah. So my question is, I didn't see a comparison with PACTree. PACTree does not take locks for writes. Have you looked at it in your comparisons, how it performs with PACTree?
Is your question about the PACTree published in HMTOS?
Sorry, say that again.
Did you mean the PACTree that is? Do you mean the performance comparison between PACTree and PACTree?
Yeah, correct.
Actually, we didn't compare with the PACTree, but as I know, PACTree is persistent PACTree, and PACTree always keep the keys for all of each B3 node. So in the cases, the comparison cost will be much higher than trie-based such layers. So it will be it will show worse performance than PACTree, I think.
So they actually put a binary search tree inside a B+tree node. So it should have only, maybe I can ask offline. I don't understand why the number of comparisons should be less in PACTree. But we can discuss offline.
Okay.
Sure, yeah, you feel free to use Slack for the offline chat. Thanks a lot. We have a question from Changwoo.
Can you hear me?
Yes.
I'm Jongyu Park from Sungkyunkwan University. Thank you for the great talk. I think this paper can be a guidance for further research about persistent memory. Actually, I read a little bit about your paper, the paper actually was really great. My question is, actually, since data structures are very versatile, as you said, do you have any particular usage case for PACTree?
Oh, that is very good question. So actually, I think this is not limited to PACTree, but auto persistent indexes can be used for the storage systems as a key component of storage systems. So I think we can also use PACTree for key component of storage systems and database systems or whatever that needs index structures for managing the data.
Also, like if I want to build a file system using PACTree index, do you have any tips or anything I have to concern? Any tips, please?
Actually, I'm not good at file systems, but in my understanding, file systems also use indexes such as Redux tree or P+tree for managing the file. So in the cases, we can replace P+tree or Redux tree to PACtrees to manage the files in the file systems.
Oh, finally, I'm just curious. Just I don't know if it's like realistic or something, but inside kernel there are many like data structures or indexes. But do you think these kind of things also replace something like key core database? I mean, structures such as like page table or any stuff like that, like any other indexes instead, or besides file system or database system, but also inside kernel core indexes?
I'm not quite sure if we can employ the PACtrees for other kernel component, but if kernel, if the kernel component requires some scan operations or something related to the range scans or something like that, in the cases we can leverage the PACtrees, but otherwise, if the kernel component does not require range scan and it only requires for the point queries, in the cases, I think PACtree is not good choices because hash tables or other indexes, other data structures can show much better performance than PACtree.
Thank you very much.
Thank you for asking.
Interesting questions. Yeah.
It was great work.
We have a question by Abhijit.
That was a nice presentation. My name is Abhijit and I'm from IIT Bombay. Oh, sorry. So I would like to ask that we are following PAC guidelines for the data structure, right? So is there any overhead that will incur due to the, because we are enforcing a policy of PACs over that tree structure? We are dividing into data layers and search layers. So will there be any overhead?
Could you explain one more time? I missed something, so I missed the point, your question.
Yeah, so we are following these PAC policies, right? For this tree, we will be following PAC guidelines. Yeah, so is there, due to this policy enforcement, will there be any overhead while doing this entire PACtree wall formation?
Maybe memory overheads or
yeah.
You mean memory overhead of the PACtree?
Yeah.
Actually, PACtree's memory utilization is better than B+tree, but it shows similar to the trie-based, not trie-based, but ART, memory efficient trie, PACtree's memory utilization shows similar memory utilizations to the memory efficient trie indexes ART. So I think our PACtree's memory utilization is not that bad, I think.
Okay, thank you.
Yes, thank you.